Hey guys, welcome back to the last video for chapter 11. What we're going to do now in chapter 11 is we're going to attack those last three categories of hydrocarbons. So alkenes, alkynes, and then we're going to take a look at the aromatic hydrocarbons, excuse me. So alkanes is what we spent the first two videos talking about, and those were all carbon-carbon single bonds. Alkenes are going to contain at least one carbon-carbon double bond. So if there is one carbon-carbon double bond, that automatically puts it into the alkene category. So that one double bond trumps anything else. If you identify a carbon-carbon double bond, now when you name that structure, it's going to end in E for alkene. And you're still going to name it using the largest chain that contains that double bond. So if you identify the double bond, that automatically becomes the main chain that we're going to talk about. Alkynes, very much related to alkenes. Alkynes is if there is one carbon-carbon triple bond present, one or more. If there is a carbon-carbon triple bond, it's automatically an alkyne. So the name is going to end in Y-N-E. Excuse me. And again, you're going to use the continuous chain that contains that double bond and end in Y-N-E. So silly way that Miss Maz remembers this. So I have really silly things in my head sometimes. This is one of them. So how do I remember alkene and alkyne? Well, if I click back to alkene real quick, when I look at this lowercase e, I kind of see a double bond in the E. So E double bond. So that's how I remember alkene is our double bond. And when I look at this Y in alkyne, I see 3 points where I can make a triple bond. So there, through the middle, and across the bottom. So just a silly little way that I remember alkene and alkyne. Somebody else very logically pointed out that alkane, alkene, and alkyne are all alphabetical. So that's a little bit more logical than my silly way. But alkane is A, that's our single bond. Alkene is E, that's our double bond. And alkyne is Y, that's our triple bond. So either way will work. So hopefully one of those works for you. All right, so naming alkenes and alkynes, really there is no difference than alkanes, except for the fact that we need to put a new ending on. And we also have to tell the viewer where that double and triple bond is. So we're going to number the carbon chain just like we did before, but now we're going to put the double or triple bond on the lowest carbon. So that's, again, left to right or right to left. And then we're also going to name our substituents in alphabetical order, but we also have to tell the viewer what carbon that double or triple bond is on. So that's the other thing that we're going to have to add in there. All right, so let's do this example together. So we want to name this compound. Well, first things first, I need to find the longest chain that has this double bond. And since this double bond is over here, I'm going to go ahead and start right here. That way I know that the chain will always contain this double bond. So I see this little kind of turn in the chain. So I want to make sure that the straight chain is the longest, that this maybe isn't the longest by accident. So let's count it. So if I start here, I could go 1, 2, 3, 4 carbons. Or I could go 1, 2, 3, 4 carbons. So notice this is still a continuous chain because I haven't picked up my pencil yet, right? So I don't have to pick up my pencil and then go to this one. So this is still a continuous chain. No matter which way I go, it's still a 4-carbon chain. So likely what you guys are going to do is say, okay, this is my main chain right here. And that sticking off is just a substituent. That's fine. Okay. So we've got our longest chain. Now we're going to number our chain. So we could do left to right. 1, 2, 3, 4. Or we could do right to left. 1, 2, 3, 4. Okay. So how do we know which one we're going to use? We're going to focus our attention on this double bond, okay? So the double bond either comes after the third carbon here between 3 and 4, or if I number the blue number system, it's after the first carbon between 1 and 2 here. Well, the blue system actually gives me that double bond on a lower number. So in this case, we're going to use the blue system to number our carbons. Because again, we're looking for the lowest number. So we're going to use this blue system. Okay. All right, so now we need to name it systematically. So I see that it's a 1, 2, 3, 4 carbon chain. So that's bute. It contains this double bond, so no longer is it ANE with a double bond, it's ENE. Okay. And then I'm going to tell the viewer where that ENE is. I'm going to tell them where the double bond is. It's going to be right after the first carbon. So 1-butene tells me after the first carbon, that's where that double bond happens. So we've taken care of the chain. We've taken care of the double bond. What's the last thing that we need to take care of? Yep, that substituent sticking up. So we still need to tell the viewer that on the third carbon, we have a methyl group. Okay. So the name of this is 3-methyl-1-butene. On the third carbon, there's a methyl group. After the first carbon, there's a double bond, and the whole chain is 4 carbons long. So go ahead and pause the video and see if you can name this molecule. All right, so first thing I see is a triple bond. So we're dealing with an alkyne. Next thing I'm going to do is look at my longest chain. So I'm going to start here. I'm going to say 1, 2, 3, 4, 5. Let me turn the corner, make sure those chains aren't any longer. So 1, 2, 3, 4. That's shorter, so that's not going to work. 1, 2, 3, 4, 5. So I could go that way. It's the same as the other one. But likely, again, your instinct is going to be, here's my base chain. These are just 2 substituents sticking up. Okay. So let's go ahead and get that onto the paper. So 5 carbon chain is pent. We've got a triple bond, so it's YNE. All right. So now we need to work out our numbering system. So left to right, right to left. So 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. The red numbering system puts this number 1 after the triple bond after the 1. The green numbering system puts the triple bond after the 5. So I'm going to use the red numbering system, the left to right system, because that's going to put that triple bond on the lowest number. So we're going to use red. All right. So I'm going to tell the viewer I've got a 5-carbon chain. There's a triple bond somewhere. I'm going to tell the viewer it's after the first carbon. So 1 pentyne tells the viewer that this triple bond's after the first carbon. We've got a couple of substituents to take care of. So these two right here, they're both methyl groups. So again, we're going to be redundant and say dimethyl because there's 2 of them, right? So on the 3rd carbon and on the 4th carbon, there is going to be a methyl group. Okay. So 3,4 dimethyl, 1 pentyne. Okay. So that's it for naming alkenes and alkynes. Again, go practice. That's going to be important. The last thing that we're going to talk about in this chapter is aromatic hydrocarbons. So this is not going to be something that I ask you to draw, but it's likely going to be something that I ask you to recognize. So aromatic hydrocarbons contain this thing called benzene. So benzene is a 6-carbon chain. So 1, 2, 3, 4, 5, 6-carbon chain. And every other carbon bond is a double bond. So double, single, double, single, double, single. And this structure, this benzene ring, is incredibly stable. We will see benzene rings pretty much for the rest of the class. There will be benzene rings probably somewhere in that structure. That's how stable they are. So we're going to get to identifying them. Often you'll see skeletal structures for these guys. It'll look something like this. So here's our 6-carbon chain. Oh, bug. Trying to make this look a little better. All right. So there's our 6-carbon chain. And then we typically draw every other as a double bond that looks something like that. Some people that are stupendously lazy, instead of drawing this every other double bond, they'll just put a circle in the middle saying around and round as it goes. There's double bonds everywhere. So both of these mean the same thing as this. These are all ways to depict benzene rings. So why do we call these aromatic hydrocarbons? These benzene rings give us fragrances that we often smell in chemicals. So when you've got different herbs or spices or essential oils, the fragrance that you get from those different products likely is the cause of some sort of structure with a benzene ring in it. So here are 2 structures that you know the smell of, and they're just fun to say. So this one's vanillin. In vanillin, we see that benzene ring right here in the middle. Vanillin is the molecule that's responsible for that vanilla fragrance that you smell. So if you have vanilla extract, vanillin is what enters your nose and your brain registers it. If you have a vanilla scented candle, likely it's been infused with vanillin. So that's the molecule that your brain recognizes. Cinnamaldehyde, another fun one to say. So cinnamaldehyde, again, has this benzene ring right here. So that's the aromatic portion of this. So we see benzene rings in these aromatic structures. So benzene ring here. Cinnamaldehyde, you would think that it's cinnamon. It's not. Cinnamaldehyde is actually almond. So again, if you have an almond extract, you open it up. Cinnamaldehyde is what registers on your nose, or anytime that you smell that almond fragrance, it's cinnamaldehyde. Okay, and again, not going to ask you to draw vanillin, not going to ask you to identify cinnamaldehyde, but I might put these molecules up and say, identify a structure, identify a functional group, and benzene would be one that you could identify here. Okay. So that's it for chapter 11. Very brief introduction to organic chemistry, but likely enough on your plate right now. It's something very different than you've ever seen before. So get out there, practice it, spend some time with it, get to know it, because the last 2 chapters of this course are going to be organic related molecules. I hope you guys found this helpful.